So now we will solve numericals for some of the process. So let us start with one process, sensible heating and sensible cooling. So for this process we will solve numerical, but before that some of the basic we need to understand. So what is sensible heating and sensible cooling? Suppose we are at this point, suppose we are at this first point, clear, and what we are doing, we are increasing temperature of air without changing its specific humidity. So this is known as sensible heating. This is known as sensible heating. So just we are increasing temperature, we are not changing specific humidity, so that is known as sensible heating. Clear? Sensible heating. Now then after, what do you mean by sensible cooling? So in sensible cooling your point get changed. So suppose you have 2 points. Suppose this is your first point, this is your first, and this is your second, and you are reducing the temperature, but you are not changing the specific humidity. So that will be known as sensible cooling. Sensible cooling. Clear? So line will be straight, horizontal line will be there. Now let us discuss about bypass factor. So for that let us see this. So suppose this is our pipeline or duct, and from here air is entering. So air which is entering, it has a temperature of TD1, and here we have coil. Here we have coil. So let us assume this is heating coil. Heating coil. And here we have outlet air. So this outlet air has a temperature of TD2. And what is the temperature of heating coil? TD3. Clear? So this is heating process. So air which is coming, which it has a low temperature. So let us assume this is 20 degrees centigrade, and this is coil is at, let us assume 40 degrees centigrade. What is the temperature of coil? 40 degrees centigrade. So whenever this 20 degree centigrade air come in contact with 40 degree centigrade, so its temperature get increased. Clear? So ideally this temperature should increase up to 40, but in reality let us assume that it reach up to 35 degrees centigrade. Ideally it should reach up to 40, but in reality how much it reach? 35. So now I want to find out bypass factor. Bypass factor. Bypass factor means how much range has left. So here it should hit it up to 40. So 40 means TD3. Now here this is the gap. આટલો ગેપ રહી ગયો છે, બરાબર ને? હીટ થવું જોઈતું હતું 40 સુધી, પણ ક્યાં સુધી હીટ થયું છે? 35 સુધી. આટલો ગેપ બાકી રહી ગયો છે. અને મેક્સિમમ પોસિબિલિટી કેટલી હતી? TD3 માઇનસ TD1. મેક્સિમમ આટલું પોસિબિલિટી હતું 40, અને આ છે 20. તો 20 ડાયરેક્ટલી હીટ ક્યાં સુધી થઈ શકતે? 40 સુધી. પર રિયાલિટીમાં કેટલો ગેપ બાકી રહી ગયો? 40 માઇનસ, એટલે 5 ડિગ્રીનો ગેપ બાકી રહી ગયો. 5 ડિગ્રી અને ભાગ્યા નીચે શું આવશે? 20. So this is how you can find out bypass factor for heating coil. So let us discuss about bypass factor for cooling coil. So let us discuss that. So here suppose you have a pipeline, and in pipeline this is air which is coming. So it has a temperature of TD1, and from here air is passing, so TD2, and here you have cooling coil, and it has a temperature of TD3. So this is cooling, means let us assume this is as 40. Let us assume this is at 10. Clear? So we are assuming it. We are not going into psychometric chart, but just we are assuming this is 40. Let us assume this is not 10. Let us assume this is 25 degrees centigrade, and 25 degrees centigrade. So this should cool up to 25, but in reality it has cooled up to 1 minute. It has cooled up to 30. બરાબર ને? કુલ થવું જોઈતું હતું 25 સુધી, પણ એ ક્યાં સુધી કુલ થયું? 30 સુધી. તો હવે આપણે બાયપાસ ફેક્ટર ફાઇન્ડ આઉટ કરવાનું છે. વી વોન્ટ ટુ ફાઇન્ડ આઉટ બાયપાસ ફેક્ટર. તો કેટલું બાકી રહી ગયું છે આપણે? TD TD2 માઇનસ TD3 આટલું ટેમ્પરેચર બાકી રહી ગયું ને. અને મેક્સિમમ પોસિબિલિટી કેટલી હતી? TD1 માઇનસ TD3. તો કેટલું ગેપ બાકી રહી ગયું છે? 30 માઇનસ 25, 5 ડિગ્રી બાકી રહી ગયું ને. અને મેક્સિમમ કેટલું થઈ શકતું હતું? તો 40 માઇનસ 25 એટલે 5, 15. So this is how you can find out bypass factor for cooling process. This is for cooling, and previous example was for heating. Clear? So now we will solve numerical in next lecture. So this is the basic for sensible heating and sensible cooling. Now we will discuss about or we will solve numericals in next lecture.